part 2 of 8.3. This is our fourth center of a triangle, and this one is called the orthocenter. And the orthocenter is defined as the intersection of altitudes. And let me explain what altitudes are. The simplest way to think about an altitude is to think about like a mountain, right? What's the altitude of the mountain? So we'll go ahead and draw this mountain. That was not a straight line. Or a level line. I just wanted a level one. There we go. Okay, close enough. Here's my mountain. Right. Snow on top. Okay. So what is the altitude of this mountain? Well, if I were to just hike up from the side, I'd be like, oh, all this distance, hooray. Is that the altitude? No, the altitude is not the length of the side. The altitude is the distance straight up, right, through the center of the mountain to the very tippy top. As you this is like down to the center of the earth, right, or essentially perpendicular to the ground. So that's what an altitude is. Is it goes to a vertice and it is perpendicular to the opposite side. We'll show a couple other examples. There's like a famous bridge somewhere that has a big triangle thing that comes out like this, and then down. It's like a, and then like the bridge hangs off this thing, right? But if I were to ask what is the altitude of this big like steeple thing, again, you wouldn't measure up the side. You would measure right here, this distance, right? The distance it's standing here on the ground. So again, we're going perpendicular to this side, this the line at least containing this segment, and we're going through the opposite vertice. So it's possible all three altitudes for this triangle are mapped here. For example, y to p. It goes through point C, and it is perpendicular to AB. Similarly, I can draw B to P. It is perpendicular here to AC, and it goes through point B. And then finally, I have AP, kind of terrible AP. Advanced placement of my foot. All right. Better. We have AP, which again is perpendicular to BC, and it goes through A. So just like the circumcenter, it's possible for the orthocenter to be outside the triangle. We don't have any big fancy theorem associated with this one. All we really are doing in these problems are just finding the orthocenter, but you should be aware of what the altitude is and how to find the orthocenter using the altitudes. And it gets actually pretty tricky. So don't get too intimidated by the wall of text. They're just writing tons of stuff down. So this one here, if we want to find the orthocenter of a triangle, we go ahead and graph the points. Boop, 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 right? Then we choose a point. In this case, we'll choose point P. They're just using that as an example. So we want to find the altitude. We know it's going to go through point P, but we're going to be perpendicular to OQ. So what's the slope of OQ? Well, it's 0. It's horizontal, right? So therefore, the slope of the altitude that goes through P is going to be undefined, right? Vertical. And the equation is what x equals 2, right? Because we go through this point. Actually, because we're going through this point. Okay, we'll do it again with another vertice. So again, we're going to go through, this time we're going to go through O. And you will find that it's somewhat arbitrary which ones you pick. Some of them may come out to a really simple calculation. Other ones may be much more difficult. I suggest just picking all three and then get halfway down them, or you'll kind of get a hand for some of these too. But it doesn't really hurt. I mean, they're all pretty hard, really. But the downside is sometimes you'll be dealing with fractions. Ooh. Okay. So the altitude that goes through O is going to be perpendicular to PQ, right? This altitude here is perpendicular to PQ. What is the slope of PQ? Well, we can calculate the slope of PQ. We go from 2,6 to 8,0. What's the difference in x's? Or I should do difference in y's. Is 6. What's the difference in x's? -6. So the slope is -1. Nope. Since the slope is -1, what is the slope of a line that's perpendicular to it? Well, it's the opposite reciprocal. What's the opposite reciprocal of -1? Well, it's 1. So the slope of this line is 1. M equals 1. And it goes through the origin. So what is the equation for a line with a slope of 1 that goes through the origin? We get y equals x. So often we're not done yet. Even though we have our two altitudes, we need to figure out where they intersect. And where they intersect is going to be called the orthocenter. Right? Is that what I said? Orthocenter, yes. Okay. Orthocenter. So we need to find this orthocenter. And we can map it on there, but we could also solve it algebraically. I'll show you how to solve it algebraically. One line is x equals 2. The other one is y equals x. In this case, it's pretty simple. We know x is 2, therefore y is 2, and it's 2, 2. Otherwise, right, let's assume it's y equals 3x plus 1. The other one is y equals negative 2x minus 2. How do we solve for two equations at the same time? Well, we would subtract these equations. If we do that, we get y minus y is 0. 3x minus 2y is 5x, or sorry, 3x minus 2x is 5x, right? We're subtracting a negative, subtracting this whole thing. And then 1 minus a negative 2 is 3, plus 3. So therefore, we can solve for x. We can say, we'll just extend it. Subtract 3 from both sides, negative 3 equals 5x, and x equals negative 3 over 5. So we could solve for x doing that, and then we'd plug it back in to find y for either equation. That's if it comes up complicated. Usually it'll come up much more simple. We'll get something like this, where x is equal to a value or y is equal to a value, and then we just go from there and plug it in. Okay, we'll try this one. Again, we have to find the altitude that contains the vertex A. So in this case, here's A right there, which is at -1, -1. And it is going to be perpendicular to BC, right? Because that's the opposite side. BC has a slope of, well, undefined. So therefore, the slope of a line that's the altitude will be 0. Okay, what is the name of a line? What is the equation of a line with a slope of 0 that goes through -1, -1? And if you don't know how to do this or don't remember how to do it, remember you can always use the y minus y1 equals m times x minus x1. If we plug in 0 for m here, this whole thing cancels out, equals 0. We're left with y plus 1 equals 0, or y equals -1. Cool. So that gives us our equation. I think it's this one. Yep. Okay, the second one, find the altitude that contains the vertex C. So C is right here. It's at the point 6, 2, 6, 2. And it's going to be perpendicular to AB. What is the slope of AB? Well, we know it's at -1, -1. It goes up to 6, 6. We can just count the rise and run. We can say, oh, 7 over 7, or 1. Therefore, the opposite reciprocal of 1 is -1. What is the equation of a line with a slope of -1 that goes through this point? Again, I can plug it in. Y minus y1 equals, I just plugged it in, sorry, m times x minus x1. I jumped the gun there a little bit. Y minus 2 equals -1 x plus, we subtracted the 6, so we're adding 6 here. Gives us y equals -1 x plus 8. I hope. Yay, okay. Or -x plus 8. That would have been all clean. Cool, 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 cool. So the question is, where do these two lines intersect? Again, we have, it's relatively simple because we know y is equal to -1. So we know the y coordinate is going to be -1. We can plug it in here. We get -1 equals -1x plus 8. So we subtract 8 from both sides. We subtract 8 from both sides, gives us -x equals -9 or x equals 9. So there's our x value, there's our y value. Cool. Here's an example. If you want a challenge, see if you can do this without graphing it. It's actually totally doable without the graph or without doing a nice clean graph. You could just like eyeball it just to sketch it out. But it can be done without graphing. You just have to keep track of what sides are perpendicular to which other sides. So go ahead and pause it here. And I'm not going to go through these, but I'll just show the answers. Oops. This one comes out to -2, -3. And this one comes out to 4, -1. Okay, that's it. That's all I got. Have a good one.